Okay. I think audible. Unvisible. So, it's audible?
Audible, ma'am, but the screen is not visible, ma'am.
Okay, okay, 1 minute. So, okay, now okay? Is it okay?
Yes, ma'am.
Okay, okay. Today we can discuss limit superior and limit inferior. Properties and what is limit superior and what is limit inferior. I already said down. What is limit superior? Limit superior an be bounded sequence the greatest limit point of an is called limit superior of an. So you find the limit values, then you find out the superior point of the limit. That is called the limit superior. Similarly, limit inferior. Limit inferior is a smallest limit point of fn. Smallest limit point of an is called limit inferior of an. Okay. If an is not bounded above, we can write limit superior of an is infinity and an is not bounded below, limit inferior of an is minus infinity. Okay. Next.
Ma'am, can you make your pencil size a little bigger, ma'am?
Okay, okay.
Size.
Okay. Otherwise, I will.
Ma'am, there's a size, I mean, beside the color, ma'am. You can change.
Okay, okay. Yes, yes. Next, this one okay? A bounded sequence. Is this okay?
Yes, ma'am.
Okay. A bounded sequence AN converges if and only if limit n tends to infinity sub AN and limit n tends to infinity inf AN both are equal. A bounded sequence, that sequence is convergent, limit sup and limit inf are equal. Next, what is the limit inf of minus Fn? That is equal to minus limit sup of Fn. Okay? Or otherwise you take a An. Limit inf of minus An equal to minus limit sup of An. Next, limit n tends to infinity sup of minus An. That is equal to minus limit inf of An. Okay, next, AN and BN are two sequence. AN is real bounded sequence and BN is convergent. Then what can you say about limit inf of AN plus BN and limit sup of AN plus BN? What is limit inf of AN plus BN and what is limit sup of AN plus BN? Limit inf of AN plus BN equal to limit inf of AN plus limit inf of BN. And limit sup of AN plus BN is same as limit sup of AN plus limit sup of BN. Have proof, but you study this statement, okay? You study this is a statement. We need to study. Didn't need to study the proof. So AN and BN have two conditions. AN is bounded and BN is convergent. Then we can say its a sum is limit sup of sum of the sequence is limit sup of AN plus limit sup of BN. Similarly, limit inf of AN plus BN is limit inf of AN plus limit inf of BN. Okay? Similarly, what is the product? What is the product? Fn Gn. Limit sup of Fn plus Gn. What is limit sup of Fn Gn? I mean An Bn. Here same as An bounded sequence of positive real and Bn convergent sequence. Positive reals. Then What is the limit sup of a and bn? And what is limit inf of a and bn? That also equal. Limit sup of a and bn is limit sup of an into limit of bn. And limit inf of a and bn is limit inf of an into limit bn. Okay?
Yes, ma'am.
But not necessary always. It's a product, not necessary always. Just given A and Bn are two bounded sequence. Here An is bounded and Bn is convergent. That's why we can write this equation. But A and Bn are two sequence. A and Bn are two non-negative sequence. Negative sequence. So what is the limit inf of a and bn? And what is the limit sup of a and bn? Limit inf of a and bn greater than or equal to limit inf of an into limit inf of bn. Similarly, limit sup of a and bn is less than or equal to limit sup of an into limit sup of bn. Not necessarily equal. But an is bounded and bn is convergent. That case are equal. But just we take two arbitrary sequence, that is not necessarily equal. Okay? Okay?
Yes, ma'am.
Okay. Next we can discuss some problems. 1 minute. So these are the some importance of sequence, theorems and all things. Next we can discuss some problems. First problem. What is the supremum of root n plus 1 minus root n and limit sup of root n plus 1 minus root n as first option root 2 plus 1 and 0. Second option 1 by root 2 plus 1 and 0. Third option both equal to 0. D both equal to 1 by root 2 plus 1. Can you try? Supremum of a sequence and limit supremum of a sequence. First to find, first you try to find what is the limit value. What is the limit of given sequence? What is sequence? An equal to root n plus 1 minus root n. Can you find limit of the given sequence?
Yeah.
Nice. We can take it's a conjugate. So we get n plus 1 minus n by root n plus 1 plus root n. So 1 by root n plus 1 plus root n. So 1 by root n, root of 1 plus 1 by n plus 1. So as n tends to infinity, this tends to 0. So limit n tends to infinity, an equal to 0. So an is convergent. So we already discussed a theorem. Sequence is convergent if and only if its a limit supremum and limit infimum are equal. So limit supremum of an and limit infimum of an both are 0. Clear?
Yes, ma'am.
Next, what is the supremum of a given sequence? What is the supremum of an? So we already get an is 1 by root n plus 1 plus root n. So you find out the supremum of 1 by root n plus 1 plus root n. So what is the a1? So you can find a1. a1 is 1 by root 2 plus 1. What is a2? What is a2? 1 by root 3 plus root 2. So this will be decreasing sequence, isn't it? Root 2 plus 1 is smaller than root 3 plus root 2. So its reciprocal is less than. A1 is greater than A2. Similarly, A2 is greater than A3. Isn't it? So the supremum is A1. So 1 by root 2 plus 1 is supremum. So 1 by root 2 plus 1 and 0 be the answer. Okay? Clear?
Yes, ma'am.
Okay. Next question. X and B sequence of real number such that summation mod xn minus x equal to c, where c is finite. Then first option, xn may not be bounded. Second option, xn must converges. Third option, xn must converges to x. Third option, xn must converges to x plus c. Last option, xn bounded but not convergent. Which option is true? Xn is a sequence of real numbers and summation mod xn minus x will be c, finite value. What can you say about the given sequence? Any idea? Any idea?
Thinking, ma'am.
Okay. Oh, I will give 4 minutes. Which option is true? Did you get which option is true? We have one.
Not be
Which option?
option A, I suppose, ma'am.
No. We know if summation an, this will be the series. We will discuss after series, convergence, etc. But here I will give one theorem. Summation an is convergent, then limit n tends to infinity an equal to 0. This is one of the important theorem. Series is convergent, corresponding sequence tend to 0. So here given that summation xn minus x modulus xn minus x equal to c. So what is the meaning? This sum will be finite value. Therefore, mod xn minus x, this series is convergent. Isn't it? Therefore, using above theorem, we can conclude limit n tends to infinity mod xn minus x equal to 0. Okay? Clear?
Yes, ma'am.
Okay, so we can write it as modulus xn minus x equal to 0 as n tends to infinity mod xn minus x equal to 0. Obviously, we can write it as xn minus x limit n tends to infinity xn minus x equal to 0. This implies limit n tends to infinity xn equal to x. So our sequence is convergent and converges to x, isn't it? So sequence xn is convergent and converges to x. So which option is right? So convergent sequence, so xn should be bounded. So first option false. Xn converges to x. Second option true. Third option false. Xn bounded but not convergent. That also false. So second option is true. Okay. Clear?
Yes, ma'am.
Okay. Next. Root 7. Root of 7 plus root 7. Root of 7 plus root of 7 plus root 7, etc. Is a sequence is converges to 1 plus root 33 by 2. Second option 1 plus root 32 by 2. Third option 1 plus root 30 by 2. Last option 1 plus root 29 by 2. Which option is right? This sequence is converges to which limit? That is the question. Is converges to
Option B, ma'am.
root B. How we can write some x equal to root of 7 plus root of 7 plus root of 7 plus etc. Isn't it? So both side we can square. So we get x square equal to 7 plus root of 7 plus root of 7 plus root of 7. So this infinity times square root of 7 repeated. Here also infinitely times square root of 7 repeated. So we can write this will be x. So x square equal to 7 plus x. So x square minus x minus 7 equal to 0. So we get a quadratic equation. So we need to find the solution. X equal to minus b plus or minus square root of b square minus 4ac by 2a. So 1 plus or minus square root of 1 minus 4 into 1 into minus 7 by 2a. So 1 plus or minus 29 by 2. We get 1 plus or minus root 29. 1 plus root 29 by 2 or 1 minus root 29 by 2. Isn't it? So given sequence either converges to 1 plus root 29 by 2 or 1 minus root 29 by 2. Given sequence converges to, so all terms are positive. So our limit also converges to positive. So 1 plus root 29 by 2 is the limit point. So last option is true. Lakshmi.
Yes, ma'am. That's what I said, ma'am.
Okay, you said root 29.
Yes, ma'am. Option D. Fourth
Okay,
option.
okay. I think option B. Okay. Okay, next question. Deebalakshmi, clear?
Yes, ma'am. Yes, ma'am.
Okay. Next question. A and B sequence of real numbers. Bn equal to an plus an plus 1. N equal to 1, 2, etc. Which of the following is true? First option, if Bn converges, then An converges. Second option, if An converges, then Bn diverges. If An convergent, then Bn convergent. An is subsequence of Bn. Which option is right? Check കൊണ്ട് കൊടുത്തടാ ആമി. Which option is right? I think we can take some counter examples. So some options are leave out. I think you can take an equal to minus 1 power n. So what is Bn? Minus 1 power n plus minus 1 power n plus 1. So here n equal to 1 minus 1 plus 1, that will be 0. What is B2? B2 also 0. So all terms are 0. So B and B the 0 sequence, it will be convergent. Okay. So Bn convergent, but what about An? An is not convergent. So first option is false. Okay. Next, second option. An you can take constant sequence 1, 1, 1, 1. What is B? and 2, 2, 2, 2. Isn't it? an plus 1. All terms are 1. So an is 1. An plus 1 also 1. So 2, 2, 2. Bn is 2, 2, 2. So an convergent, Bn also convergent. So second option also true. Answer false. An convergent, Bn divergent. Here you got Bn is convergent. So second option also false. And an subsequence of Bn, that also false. Here an is 1, 1, 1, Bn is 2, 2, 2. So an is not a subsequence of Bn. So third option is true. What is third option? An convergent, then Bn convergent. So an convergent, we can write it as an minus a converges to a less than epsilon for all n greater than or equal to k. We need to prove Bn minus some L, that is equal to, what is Bn? An plus 1 minus, here you can write a by 2 minus a by 2. That can be written as mod an minus a by 2 plus an plus 1 minus a by 2. So that is less than or equal to mod an minus a by 2 plus mod an plus 1 minus a by 2. So this will be less than epsilon by 2 plus epsilon by 2. So less than epsilon. Not a by 2. Wait. So take here you can take 2a. So here a. So you get an minus a plus an plus 1 minus a. An converges to a. So an plus 1 also converges to a. So less than epsilon. So you get bn plus 1 minus 2a. Sorry, bn minus 2a less than epsilon for all n greater than or equal to k. So here you get bn is convergent. So an convergent, then Bn also convergent. So third option is true. Okay? All other options are false. Clear?
Yes, ma'am.
Next question. X and B unbounded sequence. So, non-zero real numbers. Then, first option, Xn must have convergent subsequence. B, Xn cannot have convergent subsequence. C, 1 by Xn must have convergent subsequence. Last option, 1 by Xn cannot have convergent subsequence. Which option is right?
Second and third option, ma'am.
Second option is false. Third option is right. So given that xn unbounded, xn unbounded, so we know that xn is not convergent. Isn't it? Xn unbounded, so therefore xn is not convergent and xn diverges to infinity or minus infinity. So this possibility xn have. So 1 by xn converges to 0. Therefore 1 by xn is bounded. So every bounded sequence has a convergent subsequence. Therefore C will be right. So how to omit all other options? First option, we can take a xn equal to n. Satisfies given conditions. Xn be unbounded sequence of non-zero reals. So xn we take a n. It has no convergent subsequence. So first option will be false, isn't it? Xn must have convergent subsequence. In this example, first option will be leave out. How to omit second option? You can take a 1, 3, 1, 6, 1, 9, 1, 12, etc. So in this sequence, you can find a convergent subsequence, isn't it? You can take A1, A3, A5, etc. This subsequence is convergent, isn't it? This satisfied unbounded.
Then option A must be true, right, ma'am? We will be having a convergent sequence, right, ma'am?
Huh? Not necessary. It has
Then
no
option A
convergent.
must be true.
No, we take a xn equal to n. So in this sequence there's no convergent subsequence. So that also false. So you take xn equal to n. That sequence have a convergent subsequence or not? N sequence n
So
have
it can either have a convergent subsequence or cannot have both.
both are possible. Yes. So in the second example have say conditions are satisfied but have a convergent subsequence. So have convergence, if some sequence have convergent subsequence, some other sequence have not convergent subsequence. So both are possible. So second option also false. We already proved third option is true. What about last option? Cannot have a third option is true. So the last option will be false. Isn't it? 1 by xn must have a convergence subsequence. Cannot have a convergence. So either C or D only true. Here we get C is true. So D will be false. Okay? Clear?
Okay, ma'am.
One more question. Which of the following statement is true? f of x equal to 1 by n square plus x square, n equal to 1, 2, etc. and x element of 1 by 2, 1. First option, sequence is monotonic and 0 as limit for all x element of half comma 1 as n tends to infinity. Second option, sequence is not monotonic but f of x equal to 1 by x square has limit as n tends to infinity. Third option, sequence is monotonic f of x equal to 1 by x square has limit n tends to infinity. Last option, sequence is not monotonic but has 0 as limit. Which option is right? So first you find given sequence is monotonic or not. Then only you find what is the limit. Okay?
Yes, ma'am.
You try. Eta, ഇതിനകത്തോ? So you know 0 less than n plus 1 for all n. Isn't it? So you can write it as n square less than n plus 1 whole square. You add n square plus x square, that also less than n plus 1 whole square plus x square for all x element of half to 1. Isn't it? You can take reciprocal. What is the inequality? 1 plus 1 by n square plus x square is greater than 1 by n plus 1 whole square plus x square. So fnx greater than fn plus 1 x for all n. Therefore, given sequence fn is monotonic. Isn't it? So second option and last option are false. Clearly we can say that sequence is not monotonic. Second option, last option also sequence is not monotonic. Here we get sequence is monotonic. So B and D are false. Then you find out what is the limit. So 1 by n square plus x square. X square is greater than 0. X is an element of half to 1. So x square is also should be greater than 0. So n square also greater than 0. So n square plus x square greater than 0. So it's a reciprocal also greater than 0. So you can write it as 0 less than 1 by n square plus x square. Isn't it? And smallest value is half. So 1 by n square plus half square. What is the relation? 1 by n square plus x square and 1 by n square plus half square. X will be half, in between half and 1. So 1 by n square plus x square and 1 by n square plus half square. What is the relation? Less than, greater than or equal? Less than or equal to, isn't it? N square plus x square is greater than or equal to x square plus half square, isn't it? This x will be greater than half. So x will be greater than half. So x square is greater than half square. So n square plus x square is greater than or equal to x square, n square plus half square. So its a reciprocal is less than or equal to 1 by n square plus half square. Isn't it? Clear? So we can fix some n. We can fix some n 1 by n square plus half square. For all n greater than or equal to n. Okay? I fix some n. What is the relation of 1 by n square plus half square and 1 by capital N square plus half square? So capital N is less than or equal to small n. Therefore,
there's 5 multiplied 5
n square greater than or equal to capital N square. So n square plus half square is greater than or equal to n square plus half square. So its reciprocal is less than. So 1 by n square plus half square is less than or equal to 1 by capital N square plus half square. Okay? So we get this inequality. This inequality, is it clear? Okay. So as n tends to infinity, 1 by n square plus half square tends to n greater than or equal to n. So n square plus half square tends to 0. So we get 0 less than 1 by okay, 1 minute. Not necessarily this one. This inequality not necessary. We have this 2 1 only. We need these two terms only. So as n tends to infinity, this term will be converges to 0. So 0 less than or equal to 1 by n square plus x square less than or equal to 0. So by Squee's theorem, we can conclude 1 by n square plus x square converges to 0. Clear? So monotonic and converges to 0. Which option is right? Sequence is monotonic and 0 is the limit. First option is right. Third option also false. Okay? Clear?
Yes.
Any doubt? Any doubt?
So far, no, ma'am.
Okay. So I think we can stop sequence. Tomorrow onwards we can start series, its convergence, etc. All other properties related to series. We can discuss tomorrow onwards series. Okay?
Okay, ma'am.
Okay, ma'am.
We can stop here. So you get
Thank
any
you.
other questions, you share by WhatsApp. Okay? If you get any related questions or any other things, you share. Okay? NBHM question or any other question, you share. We can discuss by WhatsApp. Okay?
Okay, ma'am. Sure, ma'am.
Okay. Okay, bye. We can stop.
Thank you.
Okay, ma'am.
Okay, welcome.